Hello, I'm Papia. In this problem, we have to evaluate a limit, and it is this limit of the sum f of ci times delta xi. And we have to evaluate this limit over the region that's bounded by the graphs of these equations. The function is square root of x, and we have y equals 0, that's x-axis, and these are the x values between x equals 0 and 3. So let's graph the function fx equals square root of x. You know the square root of x looks something like this. Okay, y equals 0 is the x-axis. Between 0 and, say, 3 is right here. Okay, so this is the region that we are considering. All right. Now, as you can see that this limit of the sum of this expression, this is the Riemann sum. This limit actually will give us the area under the curve above x-axis between 0 and 3. The only thing that's different is, notice in this expression, we have delta xi. So that means that's the length of the subinterval. We are partitioning this interval 0 to 3 into unequal subintervals. So the length of the subintervals is delta xi. So it will be different for different I. Now in the problem, we also have the hint that considers ci to be 3i squared over n squared. Using that, we have to figure out what will be the length of each subinterval when we partition this interval 0 to 3. So that's the first step, to compute delta xi. As you know, delta xi is the difference of the two x values. So when we partition it, say this is ci. Then the previous value is ci minus 1. Then delta xi is that length. So how do we compute that? Ci minus ci minus 1. Okay? Ci is given to us 3i squared over n squared. Using that, we have to figure out what is ci minus 1. Now note, ci is 3i squared over n squared. So when we plug in I minus 1 for I, all we have to do is plug in I minus 1 wherever there is an I. So it will be 3 times I minus 1 squared over n squared. Okay, so let's plug that in here. 3 times I minus 1 squared divided by n squared. Now it's best to simplify it because we have to evaluate this summation, and then we have to take the limit. Okay, note that from both terms we have common factors 3 divided by n squared. And then from the first term we have an I squared minus, from the second term we have I minus 1 squared. Okay, we can simplify this further. Keep the I squared as it is, and then expand I minus 1 squared. Be careful, there's a negative sign in the front. So you will have an I squared, you'll have a negative 2i, with a negative will be positive 2i, and then you will have a 1 squared, with a negative, it will be negative 1 squared. And so I squared cancels, and you will have 3 over n squared times 2i minus 1. So this is the expression for delta xi, which is the length of the subintervals when you partition the interval 0 to 3. All right. Now we come back to this limit expression and then plug in everything that we have. So let's see. We have a limit, and then we have the sum, I equals 1 to n. Okay, we have to figure out f of ci. Now look, f of x is square root of x, so f of ci will be square root of ci. And then delta xi we have calculated right here. It's 3 over n squared times 2i minus 1. So next step, let's figure out or plug in Ci and then simplify that expression. Okay, we'll have square root of, let's see, Ci is right here, 3i square over n square. And then we will just have 3 over n squared times 2i minus 1. Okay, let's see if we can get rid of the square root. Okay, we'll have a square root of 3, and then I square and n square with the square root, you will just have an I over n. And we will still have 3 over n square, 2i minus 1. Okay, notice that this summation is over I. So I is the variable, everything else is a constant. So you can pull out all the other constants outside the summation, but keep it inside the limit. Okay, so let's see. We will have 3 square root of 3, and we have divided by n cube. Pull that outside the sum, and inside the summation, we have an I and a 2i minus 1. So we continue. Notice that inside the summation, if you distribute this I, you will get 2i square minus I. Now we can break this expression up and we can have two different summations. And notice that we have formula for summation of I square and summation of I from 1 to n. And we can use those formulas and then we can continue. So I will break this sum into two summation. One is summation of I equals 1 to n of 2 times I square minus summation I equals 1 to n of I. All right, so now we have to write down the formulas and then we have to evaluate the limit. So let me erase this portion of the board and we'll continue the problem here. Okay, so we continue our problem on this side. So we have our limit as n approaches infinity. So the constant is 3 square root of 3 over n cube. And then we have the 2 summation. So let's write down the formula. So the first one, 2 is just a constant, you can pull it out. So to figure out what is summation of I square, I from 1 to n, and it is n times n plus 1 times 2n plus 1 over 6. For the second summation, it's just summation of I from 1 to n. So minus, that is n plus 1 over 2. So before we evaluate this limit, we have to simplify this expression inside the bracket first, and then we can evaluate the limit. In order to do that, let us add these two expressions together with a common denominator. Okay, so common denominator is 6. The numerator of the first term, you just keep it as it is, 2n, n plus 1, 2n plus 1, minus, for this next term, we'll have, since we already have the 2, we'll have 3 times n plus 1. Right, let's continue. Okay, so we have 6 in the denominator. Instead of foiling everything, always look for common factors in both terms. It will make the simplification easier. So see that both terms you have n and n plus 1 and n plus 1. So that's the common, those are the common factors. So you can pull them out, and what is left from the first term, you took out n and n plus 1, so you will have 2 times 2n plus 1. Second term, you will have just negative 3. Okay, so now we keep our n plus 1, and let's see what we have here. We have 2 times 2n, so 4n, plus 2 times 1 minus 3. Okay, you can start cancelling if you want. So you have an n, which will cancel with the n cube. To have an n square in the denominator, we can cancel the 3 with the 6. So we will have a 2 here. Okay, so we'll have square root of 3 over n square. And on this side, we have n plus 1 times 4n plus 2 minus 3, so that's minus 1, divided by 2. We can now pull out the constant square root of 3 over 2. And inside the limit, now we have to FOIL the numerator. So let's do it quickly. N times 4n, that's 4n square. Then we have negative n plus 4n, so plus 3n, and then negative 1, divided by n square. So what you can do is you can divide each term in the numerator by n square, and then take the limit. So let's see, inside the limit we have 4n squared divided by n squared, we'll have 4, plus 3n divided by n squared, so that will be 3 divided by n, and then minus 1 divided by n squared. The reason we do that is because as n approaches infinity, 1 over n will always approach to 0. So you know that this term will approach to 0 and this term will approach to 0. So the limit is 4. So the answer is square root of 3 over 2 times 4, which is equal to, you can cancel 2 and 4, so it will be 2 times square root of 3. You can use a graphing utility to figure out what the value is in decimal. So 2 times square root of 3 is almost equal to 3.464. So that is the answer for this limit of the sum of f of ci times delta xi. Thank you.